we are going to be talking about Graham's law. Graham's law actually states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of their molecular masses. And so, basically, we are going to be determining that today. We want to use the rate of diffusion of ammonia and hydrochloric acid to determine their molar mass. We're going to be using it to determine the molecular weight. So we have the rate of diffusion of gas A and the rate of diffusion of gas B, and maybe we would have the molecular mass of gas A or B, either one of them, and then we'll be able to use this rate of diffusion to actually get the other molecular weight. And what we want to look for in this lab, we are going to be using a glass tube. What we want to look for is a formation of precipitate, right, maybe somewhere around. One of the gases will actually move faster, so we want to see how they react together. Gases move randomly, but eventually they are going to kind of collide, and they are going to form this white precipitate, which is ammonium chloride. And so that's what we want to look for today. So, enjoy! We have two of our reagents, which is ammonia and HCl. Both of them are 6 molar, and so we expect that they are going to do the same reaction. And we have our glass tube here. We also have our wool, and that is what we are going to. We have the wool, so I've cut out a piece of them. I'm going to soak this wool into the two different reagents, and after we are all done, I'm going to just dump those ones because these chemicals are actually corrosive, so you don't want to play with any of them. So I'm going to dump the wool inside the water so that there is no form of exposure to chemicals. And so I'm going to pour a little bit of my ammonia. I'm going to soak the wool into it. And I'll do the same for the acid. Also, make sure you're working in the fume hood because you don't want to get exposed to these chemicals. There you go. And one thing though that we have to take note of is both of these wools have to get into the glass tube at the same time, and so we have to watch them carefully because if they don't get in at the same time, then there's no good judgment, if I may put it that way. So watch as I do this. So I have them in my hand. There you go. So here you go. Let's see what happens after a while.